What's going on, everyone? This is uh, you're watching biology classes, and today I would like to tell you. Today I would like to discuss one of the problems, and uh, today I would like to discuss how very large instruction words works. Okay, so we read in superscalar we do dynamic scheduling, but in case of VLIW we statically exploit parallelism. So, you know, how did, how did we do superscalar control logic scaling? So it was like, hey, we had an instruction set, we have the width, we had an issue width of W, and that consisted of instructions that can. This means that can consist instructions, W instructions, or proportional to the W instruction into it. So this is the issue group, you know, and the instruction within it can uh, can be. So what we need to do is, let's say we pick the instruction from the issue. Let's say we put one instruction from the issue width, and we need to check the status of the currently issued instruction. We need to check the status of the currently issued instruction with all the other previously issued instruction. We need to check the status of currently we need to check the status of currently issued instruction. We need to check the status of currently issued instruction with all the previously issued instructions. And let's say the instruction, let's say the lifetime of the instruction is L. This means that an issue can stay within the processor. So within the processor pool, it would be kind of evacuated through the processor in lifetime L. So we need to check the status of currently issued instruction with all the other previously issued instruction. Okay, so it would require time that is proportional to W cross L. That means it would grow with the size of the hardware. So if the instruction width is wider, it becomes difficult to find W independent instruction. So if the instruction width is wide, it becomes difficult to find W independent instruction. So it's like, if the instructions are independent of each other, then we can put it inside the issue width. If the instructions are not independent of each other, it means that they cannot be put inside the issue width. So it is very difficult to find the independent instruction to put it inside the given issue width. So we need to find enough parallelism. So we need to find enough parallelism. So if the machine is in order, dealing with the scoreboard is when the machine is in order, so the time required is only spent in dealing with the scoreboard, and that is kind of a reasonable time. But if, let's say, your machine is out of order, so we have two kind of machine. In order, it would take reasonable time. Out of order, it would take a lot of time. Out of order, it would take a lot of time, and the life time would be issue queue, would be the time taken within the issue queue plus scoreboard plus when the value would be available when the value of the instruction that would be available. So that is broadcasted. So all these things, when the value that would be available, the time when the value would be available, that is being broadcasted to all the instruction in the waiting or pending queue. Okay, and we that out of order kind of grows exponentially. Out of order grows exponentially. Out of order kind of grows exponentially. Yes, out of order kind of grows exponentially. And we know that out of order kind of grows exponentially. Not even like in square times, or in w proportional to w, it kind of increases exponentially because it includes the issue time in the issue the time required to issue the queue, plus dealing with the scoreboard, and then the value, broadcasting the value when the value would be available, sequential source code. Let's say we are given super compiler. Let's say we give super compiler with the sequence of instruction. Let's say we give super compiler with the sequence of instruction, and that super compiler uh, and that super compiler uh, kind of broke down that those instruction set into dependency, into into the dependency, and make a path of it, or the scheduling operation for it, and it is passed on to the superscalar processor. Superscalar processor does re-evaluation of the dependency, and it does not consider the parallelism inside that was given by the superscalar compiler. So, and then the superscalar processor schedules the instruction. That's it. So for more update, just stay with me till then. Jai VLIW.